Good morning, everyone. Erin here at Softree. Thank you for joining us today for the webinar. I have with me Dr. Alexei Gieg, and he and I will be presenting this 30-minute webinar today on Earthwork optimization as a tool to allow you to think beyond balancing. First of all, welcome back to our regulars, and if this is your first time joining us for a webinar, thanks for coming to take a look at us. Softree's been developing site and corridor design software for the last 20 years. And really at the core of our company, we have a very user-centric philosophy. We focus on engineering over drafting, and more importantly, we strive to make our software simple and easy to use. And hopefully you'll see that in action today. A couple pieces of housekeeping. First of all, and I say this every time, but you are all muted. But that doesn't mean we don't want to hear from you. So if you have a question to ask, and please, by all means, ask questions throughout the whole presentation, you're going to need to do it using the question pane of your GoToWebinar panel. So if you kind of, I think it's the second or third box down there from the bottom, you can type in your question. Both Alexei and I will see that. We may not get to answering it right away. Sometimes it makes sense to finish the example or what we're talking about before we go ahead and answer that question, but don't worry, we will see it and we will get to them. And then secondly, we're recording today's webinar. So in the future, if you sign up for a webinar, can't make it, you rest assured that you will get to see it just after the fact through a link. And with this webinar, you can watch it again or pass it on to other folks you think might be of interest. So what are we talking about today? We are talking about earthwork optimization, and specifically looking beyond balancing. This demonstration is going to be done in our Softree Optimal program, which in today's demonstration is actually going to be shown to you within the RoadEng environment. That's our primary corridor design software. However, in the very, very near future, it's actually going to be a completely standalone program. So for those of you who might be AutoCAD users or Bentley users, it'll be completely standalone outside of that. So the program itself is going to have full compatibility with RoadEng, with AutoCAD in both the DWG and DXF formats, as well as with LandXML. Now, Optimal has a couple primary functions. First off, it's all about helping you to generate a vertical alignment that minimizes your earthwork costs, saves engineering time. But what you're going to see, it's also a great comparative tool and an engineering tool that's going to allow you to basically maximize your time and minimize the costs. So what you're going to see and what Alexei is going to be covering today is going to be, first off, an example of a balanced alignment. He's then going to move over and start comparing two balanced alignments, finding the best balanced alignment, and then lastly, looking at what that looks like when it's extended over to horizontal alignments. And finally, before I pass it to Alexei, just a couple notes about some other upcoming webinars we've got. All of these are available for sign-up on our softree.com website. And from the homepage, kind of halfway down, you'll see a link that says webinars, and you can sign up through there. Okay, enough from me. I'm going to pass it now over to Alexei, and he's going to start taking us through earthwork optimization beyond balancing.
Thank you, Erin, for the presentation. Good morning, everybody. I think Erin said everything already. So this presentation, this webinar is about earthwork optimization beyond balancing. I hope that everybody is hearing me well. As Erin mentioned, you are welcome to type question. I will try to answer them as the webinar goes. Otherwise, I will answer them at the end of the presentation. Here's the example I'm going to showcase in this webinar. So this is a typical, I would say, resource road. We have a pretty complex terrain here, and I'm not going to show that to you, but the cross section are quite simple. And here is a proposed horizontal alignment for this this project. So let's move on to look at the profile, so the vertical alignment. So here's the vertical alignment that is coming with this horizontal alignment. And below you can actually see the corresponding mass flow diagram. So the point here I want to make is that the mass flow diagram, as you can see, it's balanced here. at the end of the alignment, the cut equal to the fill. So this is a proposed alignment. It's actually quite easy to tweak the vertical alignment to come up with a different balance alignment. You just have to move around the IPs right there. I've done that actually, and that's what I call here Hand Design 2. So let me click on that Hand Design 2. So here's the Hand Design 2. The alignment is in green. So let's zoom in a bit. So as I said, I just tweaking the alignment, the IP, sorry, that you can see that they are pretty close together, right? So let's just like browse along the alignment. So here it's getting a bit far apart, and that's probably here where the difference is the biggest. So let's just measure it for just curiosity, and here I get exactly. Hold on. Yeah, I'm getting actually 2 meters. No, not even that. 1.5 meters. So you can see that these alignments are very close. So the mass flow diagram below is still the mass flow diagram of the first alignment. So I need to make that current, which I'm going to do now. Okay, so let me zoom back a little bit. So that's the mass flow diagram of this Hand Design, this new alignment. So you can also see, and that's the point of the seminar, that it's also balanced. And yeah, so I'm just going to zoom out a little bit more. Yeah, so you can see it's actually balanced. So now my point, and the point of the seminar is really how to compare those two alignments. So we have the first alignment, it is balanced, and then we have the second alignment, it is balanced. And really the question is that, okay, what is the best alignment between those two? So we can use, of course, the cut quantities, the fill quantities. We can use the mass flow diagram, but these are more qualitative measure for comparing two alignments between each other. So what we have done with Softree Optimal is we have come up with a quantitative measure to compare two alignment, and the natural quantitative measure is, of course, the cost of building a corresponding alignment. So at this point, and I'm going to describe it to you, the cost we are considering in for comparing alignment is really the core construction cost. So we have the excavation cost, we have the embankment cost, and we also take into account the movement cost. So for each alignment, we are going to calculate the excavation, embankment, and the movement cost, and this will give us a total cost, and that will allow us to compare alignment between each other. So the best alignment will be the alignment with the lowest cost. So if I do that, so let me come back to the first alignment here. So I'm going to do a recost. I'm going to cost the alignment. So that's the answer. So if I go in this panel here, just going to increase the size of the panel a little bit. Hold on. There you go. So here, the cost is being provided here. So you can see that this alignment is being costed at $72,000, and you have the detail of the cost, like cut cost, fill cost, and hole cost. And let's go now to the second alignment. I have tweaked from this one. So and then if I do a recost again, okay. So what I'm getting is like a cost of $90,000. So if I actually compare with the okay, this is a bit, that's not the resolution I'm using normally, so everything is a bit squished here. Okay, let's just take this out here. There you go. Okay. So here you can see the comparison. So between the the hand design I have tweaked and then the original hand design, you can actually observe the difference in terms of cost. So there's a 20% improvement in terms of the total cost Same thing for the cut cost, fill cost, and there's a little better for the whole cost. So these costing procedures allow us to really compare two alignment. Just going to put that back. It really allows us to compare two alignments with a quantitative measure. So what is quite interesting about this is that it allows us to do what we are called design time costing. So once you have this costing in place, then, and that's your original alignment by here. So you can, and I'm going to do it right away. So you can essentially cost your alignment as you changing anything related to the alignment. So EIPs and any other thing. So for example, here I'm just going to move slowly a little bit this IP along the slope here, and then in real time, the new cost is being calculated. So that means with this tool, you can do real-time costing in the sense that you have a real-time feedback for every change you're actually making to the alignment. So I can redo it here. Let's just move that a little bit down, for example. So that was 76,000, and then the cost now raised to 91. And of course, but that's also already a feature of RoadEng. The mass flow diagram is also updated on the fly. So I mentioned that our costing now includes cut cost, fill cost, and earth movement cost. So for the next version of Softree Optimal, we are actually implementing a more comprehensive costing, which will include, for example, curve layers above subgrades, and so on. So the cost will even be even more accurate with respect to the final cost of the project. Okay, so I'm just going to pause a little moment here. Yeah, okay. I'm going to answer the second question. The second question from Will Morrows. Hi, Will. Thanks for your question. If the material is being moved uphill, the cost will not be cheaper. Yes. Okay, that's an interesting question. So to answer this question, this is it essentially goes to our cost structure here. Our movement cost, our all cost, is a bit sophisticated. It allows to take into account free-haul, overhaul, and haul. So what's going to happen is that if you actually have to move uphill, and that will go into the hand-haul categories, and that will be actually more expensive. So to answer this question, this is actually embedded into this the movement cost structure that we have here. I hope this answered the question, but I can come back to it eventually. So we have this design time costing that we can perform, but actually the really neat thing about Softree Optimal is that it's really what we call the full optimization. So we have developed this mathematical model that allows to essentially compare all the possible balance alignments together and come up with the best, with respect to the cost I have just introduced. So the way it works is quite simple. You have here a tab where you actually set up the options or the standards that you want to impose for the specific roads you are want to design. So in this case, it was quite simple. Here, what is quite important is I set up the minimum grade, the maximum grade, and I set up the proper curvature. You could also set up control points. So here, because it's an extension of an existing road, I just essentially tie down the start of the road to what was already existing. And of course, because I'm looking at what is the best balanced road out of all the possible balanced road, then I'm not taking into any pits into consideration. So there is no pit. So that means the road that will be searched for will be the road with the best the best balanced road. So essentially, this procedure is going to look at all the possible options that you have out there, and it'll essentially come back with the best options. So I have this process. It takes a little more time than the costing. So I'm not going to do it, during the webinar. I've done it before, and essentially, so let's just do it. There you go. Oh, shoot. Okay, so well, we'll have to bear with me, so I will answer some of the other questions if there is any while this is happening. So I don't see any other question, so we'll just have to wait. For some reason, this had done it before the demo, but I must have done something in between. So just bear with me for like 2-3 minutes. So yeah, so these are essentially we are preprocessing some data for calculating the best alignment. So this is, as you can see, this is a fixed amount of time, so this is actually not such a big deal.
Alexi, you should entertain everyone with your sense of humor.
Oh, I'm too focused.
We do have another question, though.
Okay, so Tyler, okay, I think Aaron, you can answer Tyler's question. So okay, so here, the optimization proper is actually being done. So this is a process, as I said, that take a bit more time. You can essentially, as soon as you have a solution here, you can cancel anytime you want, and it's just a matter of how long you are willing to wait. So essentially, this last number here indicates how close you are to the best solution. So here, essentially, it means that you have still 10% of possible improvement. We don't really have too much time, so I'm just going to cancel it right away. Okay. So I'm just going to change here I'm just going to change, it's not very pretty, so I'm going to change the line type here. Okay, so that is the best alignment that is being provided. We have actually stopped before the end. But what is important is, let's just look at the cost. So you can see here the cost is like $58,000, and whereas the original design, as you can remember, was just because it was, I changed it in the process, but it was actually more 70,000. So what is actually very interesting here is you can see that if I actually browse along the alignment, and I think this is a really important message I want to send, is that the alignment actually looks like very, very close. The biggest difference is probably here. Again, if I measure it, that is 2.6 meters, but that's only at this location. So the alignment are pretty close, but this actually, as you can see, makes a pretty big difference in terms of the cost. So let's just check before moving on to the next topic that we indeed got a balanced alignment. So that was the one I created originally. So let's have a look at that's the Mason diagram here that I had, and that's the one that the Softree Optimal came up with. So let's just set it current. And you can definitely see that it's, qualitatively, it's actually, so it is almost balanced here. And then you can see that qualitatively, the mass flow diagram looks much better. You almost have no earth movement, and if you and the top here, so the excess of cut and fill are never very large. So this is definitely qualitatively a much better alignment, but this is confirmed by this costing procedure that we have. So again, two things before I move on to the next topic here. So with Softree Optimal, you have this design time costing capability where as you modify your design, you can actually see the impact of your design in terms of the cost, so in a real-time fashion. So this is the first interesting feature. The second interesting feature, which is a bit more advanced, is that you can search for the best balanced alignment. This is the second thing I've done, so this full optimization. And then there are, now that we have these tools, well, there is actually other extension that you can have, that you can make. So, and it is actually about comparing now horizontal alignment. So if I come back to the plan view, which is here, so that was the horizontal alignment as I actually proposed. So I changed, unfortunately, the original design here, but I remember, if I remember well, the cost was about $70,000. But there is no there's actually other possible horizontal alignment that you could design, of course, to get to your final destination. And then the same question comes up, which is, okay, if I design another horizontal alignment, then which one is the best, right? And which one is the best? Again, we can answer this question through this costing procedure. So here's the first horizontal alignment I had, and here I'm going to move a second instance of location right away. Oops. Okay, there you go. Okay, so here's my second instance of the road edge. So you could see that the first alignment was going to be above the hill and then skirting around here, while the second alignment is going below the hill. So this is another second possible horizontal alignment. And again, I come back, what the question is, okay, what is the best one? And the best one is the one that will be essentially the cheapest cost. And again, you could generate the cost, which I did here. So so I got $74,000 for that road. So I'm just going to move that over for a second, and I'll come back to the original one. And the original one right here. So I'm just going to open it again so we can see what is the cost. Okay. It's going to take a little time, so I'm going to look at the question at the same time. I'm a bit silent here because I'm thinking about the question from Tyler. Just before I come back to your question, Tyler, I think I can answer it. So that was the original alignment. So again, the cost was $72,000. And here, for if I move back up to second vertical or horizontal alignment, okay, I got a little too many windows out here. There you go. Okay, okay, it's here. And the cost is $74,000, so quite similar, but the difference could be quite drastic. So in this case, the first alignment would be retained. So let me answer to your question, Tyler. So I'm just going to answer tell what is the question. Is there a way to get optimal to have the subgrade made out of a % of a certain material through the wall alignment, say 90% of rock and 10% composite? Let me think a second for that one. Yes. Okay, the answer is yes. This is actually a bit of an advanced question, so I might lose some people, but I know Tyler is already a user, so I'll answer. So if you go here into this cost panel, this is where we actually defined the materials that are being used along in the design. So in this case, we just only have overburden, but it's actually possible to create new ground type, and this ground type could be composite material. So composite material will be material composed of, for example, it could be some OB and some overburden, some gravel. So I could call that, let's say, I'm going to like composite CO. Just going to composite material. Composite material. Okay, I'll just check that up. And once I've done that, if I go into design, then I can actually here set up what is this material is composed of. So in Tyler question, it was a solid solid rock, let's say, for 90%, and then for the rest it will be, for example, OB. Okay, so here we have created this composite material, and then this composite material could be assigned as along the road as would be overburden or gravel or solid rock. So I hope that answered your question, Tyler, and if we can actually discuss that a bit further. You can send me an email if you want. So that's kind of conclude the presentation about for today. Well, I'm going to thank you for your attendance, and I will give the word to Erin for closing the presentation. Again, thank you very much, and then I hope to see you soon in other of our webinars.
Excellent. Thanks, Alexi, and thank you all for joining us today. If you do have any other questions on optimization, certainly feel free to email us here. You can get us at support@softree.com, and we can make sure that Dr. Geek here gets your email and can answer your questions that way. So again, if you have any other questions, support@softree.com. Beyond that, thank you all for attending, and have a great rest of your Friday. Cheers.